Otherwise, I'll be giving away bank details. Okay. Hopefully you guys can see it. If not, put it in the chat and I will begin. Okay, cool. All right, so blockchain is what we're going to be covering today. So in the beginning, trading was easy. You would take your clay pot or whatever and you'd give it to the other clan for a spear or whatever they did. Relatively easy. I mean, you might have got killed or something. I don't know how these guys were, but now there's as society gets more advanced, the trading becomes more complicated. There's a bunch of systems and stuff that money and has to go through, and so that results in these middlemen, basically banks or any kind of place that holds your money. So like Amazon or PayPal or Bank of America, you would put your money in there, and then they hold all your money. If you wanted to send money to someone else, you would have to go through one of these banks like this. Amazon's kind of it's a way to trade goods for money. So I guess it's one way to trade, and like Amazon's like that middleman. I think that's like the point that I was trying to make. So what we want to do, what Bitcoin and blockchain attempts to do, is to eliminate these middlemen. And we want to go from this complicated thing to this simple process, where the guy just sends the Bitcoin to the other guy. Let's go move on. Right. So in Bitcoin, in blockchain, which is how Bitcoin works, there is no central authority. When we have these central authorities in our systems currently, we are more vulnerable to corruption and abuse. These banks can go bankrupt and lose our money, or they have basically control over this, and they are relatively unnecessary middlemen, at least. So again, we want to decentralize it. Right now, like for example, eBay is the central node, I guess you could call it, like the central dot. We give our money to eBay. eBay gives us our money, or our whatever our goods are, right? And that's how they're connecting these two people. eBay is like that middleman in that sense. But what blockchain does is it makes the network distributed. So there is no central power or central central power, central controller of all the goods and that manages all the goods and trading. So in a blockchain, everyone holds a record of all the transactions on their computer and can interact with this record. And this record is called a ledger. Essentially, a ledger is a list of all the transactions. So here's an example. You get a loan from a friend and you would write down how much that is. And you would get another loan, you'd write that down. And if you send money, you would write that down. If you receive money, you would write that down. So it's basically just kind of a list of all your transactions. And usually your banks would have something like this, just a list of all the transactions. What's different in, actually we can just go into this. So, whoops. Okay, so let's say you wanted to pay Alex for watering your plants. You want to pay him close to $100,000. You would use the blockchain to send it to him directly instead of going through this process. And we'll cover exactly how this stuff works. So yeah, I think I messed up the arrangement of the slides a little, but that should be fine. So yeah, again, everyone has this ledger, and what this does, it distributes the control and of the trading, and not just the bank has and in the previous system, only the bank knows what is being sent and what is being taken in. But in this system, everyone knows what the transactions are that are happening are. And so actually we can go to this kind of website, and I can put this in the chat, I guess. This is the actual ledger. Ledger, again, is just a list of all the transactions for Bitcoin right now. So these are actual transactions that are happening, and these are public. Every time you make a transaction with Bitcoin, it's public. Anyone can see your transaction. So right now, someone just sent $850,000 worth of Bitcoin. So almost 16 Bitcoin. So I don't know, they might be doing some illegal stuff. I don't know. But yeah, so you can see it, and it's public. I have this on unconfirmed transactions, and I can turn that off so you can only get confirmed ones. And we'll get into what makes an confirmed and unconfirmed transaction. So far we know that it's a distributed network, and that there's a ledger. Basically, there's a list of all the transactions, and it's public. But the only difference is this public the main difference is that this public ledger is encrypted, so you can't see who it's successful man on the left. I don't know. Actually, I have no idea. I just found this on the internet. I searched up successful man on the internet, and this is what came up. Sorry. So except it's encrypted. If I go back, can I not? Oh my god. Dang it. Okay, there. If I go back, you can't tell anything with this information really, like who it's being sent to, who is sending it. But it's the information is there. So yeah, this is a more in-depth understanding of what it is really doing. And I found this online, and I just basically copied and pasted, but it's the best explanation I could find that wasn't like extremely technical. Basically, so how does blockchain mining and transaction work? So the user signs off on a transaction. So you would send your money right now. You would send let's say 1 Bitcoin to your friend, and you'd use your app or whatever, and you send it. This transaction is now broadcasted and waiting to be picked up by a miner. And we'll get into what a miner is. If it's not picked up, it basically goes in a queue or a waiting area, or it's called a pool. And pool is just the collection of unconfirmed transactions that are waiting to be processed. So each transaction needs to be processed to make sure that it's a legit transaction. And so when a miner selects transactions from this pool of unconfirmed transactions and forms them into a block, and this is where the blockchain comes in. A block is essentially a collection of transactions, and these transactions at this time are unconfirmed. So basically, we don't know if they're legit or not, in a sense, if they're real transactions. So every miner has their own block of transactions, but multiple miners can select the same transaction. So I have my own block of transactions, which means that let's say I have like 5 different transactions that I need to verify. someone else can have their own block of transactions with like maybe like one of my transactions. The transactions can overlap to different blocks. Is basically what I'm trying to say. So to add the block of transactions that a miner has, it first needs a signature. Then this signature basically permits it to move on, and it confirms the transaction. It says, yes, this is a real transaction that's being made, and it's this is not some kind of fake transaction that's trying to fool the system. So the way they confirm it is by solving an extremely complicated mathematical problem that is unique to each block of transaction. So by solving this block of transaction, you will confirm whether or not this is legit. And I can go more into detail on why this is, or what this mathematical problem is. It's essentially the hash function that we talked about earlier, I think in last meeting. So essentially, this is a hash, right? This is just a random string of numbers and letters, and it's something that's that to check, you can't reverse it. You have to kind of find out what that original number or string was. So the mathematical operation is essentially going through like infinite, or not infinite, but just going through many numbers to figure out, or strings to figure out what this hashes to, right? We're trying to find the original thing. And to do that is a lot of computational power. You just have, it's basically just brute force. If we do it on our own, personal laptop, it's gonna take forever, or we'd have to either get really lucky. So essentially what happens is that you have to, oh, I have a chat. Really? Where is it? Oh, well. Am I just blind? Whatever. I see. Yeah, it goes by quick. But so what these miners do, if you're interested in Bitcoin mining, miners essentially try to find out what the original hash is, because they want to confirm whether this is a real transaction or not. Now, it is my understanding that the Bitcoin transactions will start with a series, like a number of zeros, and it's some number of zeros. And when you decode this hash, you check if the number of zeros is correct. So let's say the number of zeros in the original transaction is like 4. And this is not the amount. It's not like when you dehash this, you get like the amount, like which is this. This is just something separate. When you decode this, you will get something. And if it starts with like 5 zeros, then it's correct. And you raise your hand and say, hey, I got it. Yeah, those come and go. You raise your hand and you say, okay, I've got it, and everyone else comes in and they confirm what you did, and they verify whether what you're saying is right. And basically they just input whatever you found as the original thing into the hash function, and if it matches up, then you're right, and it gets confirmed, and it gets confirmed, and it gets confirmed by all these different networks, all these miners that are there. And if you're like the first, or you get a piece of Bitcoin. But to do that, and that's called Bitcoin mining. But to do that, it's a very extensive process that requires a lot of computational power. Um, and as more users, as more transactions happen, the encryption becomes more and more complicated. So if there are um, like then if there are like a million, I don't know how many transactions, but if we were to reach an age where there are like a million transactions a second, the encryption would have to be very, very powerful, um, because the number of miners would be increased, and it would be easier to uh, I guess like reverse this or block it in some way. So they so you technically can be a miner. It's essentially what a miner does, as I just said, is it just tries to dehash or like decode the hash in your block transaction block. But the probability that you will actually get the hash correct is very, very low, which is why you need to be able to do like millions and billions a second if you're gonna get it, if you're gonna be the first one to get the um if you want to be like the first one to decode it, because the first one to do it gets the Bitcoin. So if the person with the most powerful computer theoretically should be the one who gets the most Bitcoin. So you can be a miner, but you'll probably not achieve anything and not contribute anything, because whatever you do in like a minute takes supercomputers that are working on this, like buildings of supercomputers will take like a second. So that's why, yeah. Um, I know, right? Um, where was I? I guess I'll just read it. Right, the block first needs a signature, and this signature is created by solving a very complex mathematical problem unique to each block of transaction. Um, every miner will work on a different problem unique to the block they form, and each problem is equally hard to solve. The miner that finds an eligible signature for its block first then sends this block and its signature to all the other miners. So basically, this means that they have decoded it and they've found the signature. Other miners now verify the signature by taking the string of data um, and hashing it to see if the hashes match up. If it's valid, then the other miners confirm it, and the block can be added to the blockchain, which then confirms it's the transaction, and then it moves on. But no one knows who sent it and who received it, because it is not centralized. So that's kind of what I had for blockchain. I wanted to do something about how a hash function works and making our own hash function, kind of. So but I didn't really have enough time to kind of write it all down. But essentially, a hash function, as I described earlier, given one input, it returns an output. Therefore, it's a function. But it's easy to verify, but very hard to reverse. So whatever output you get, it's very hard to go from the output to the input, but it's very easy to go from the input to the output. And so we can kind of make a makeshift hash function. So I'll make a table here, and let's go here. Okay, so I've just entered some random values here. And if this was our input and this is our output, this can be kind of, I guess, in some way, a hash function, because each input has only one output, right? One has two. Nothing else is going to give you two. But the problem with this is it's very easy to reverse. If I gave you the hash 8, you could probably tell me pretty easily that the input that gave me is 7. So that's not a very good hash. You want it to be very hard to find the input, is what it is. So this isn't really that good of a hash. Now, if I were to maybe make something like this, maybe. Oh wait, I messed this up. Okay. So now if I gave you 1 and 2, 2 and 5, 4 and 17, 6 and 37, 7 and 50, it's a bit harder actually to go from, you know, I don't know, 101 to the original number. It's not too hard, but it is a bit harder. I think what I was going for, and it's a bit harder to go from here, from the output to the input here. Sorry, I need to check the chat. Yeah, the function is not linear. I mean, I can show you. Can I reduce this chat box? It's quite big. Okay, whatever. Can I do this? Okay, sorry. Yeah, let me show you the thing, which might give you a hint at what the function might actually be. Oops, sorry. This chat box is like really big. Okay. So it's actually just x squared plus 1. I hope I did my math right on these. And so that's our hash function, right? Given the input, we get an output. So if we were to reverse it, we have to -1 and take the square root. And we can see that that's a considerably more difficult function to reverse, right? But it's quite easy to verify. If I told you, check if 10 goes to 101, well, you can do that quite easily. Just say 10 squared plus 1, and you can figure it out. There was also something else, I believe. Wait. Okay. So there was another example is of how to make a hash function, or the classic example is choosing two prime numbers, and the output is the hash. But at both the sender and the receiver know the two numbers, and so that can kind of be like the password, I guess. So you would have to figure out what are the two prime numbers that kind of multiply to this. And just kind of off the top of your head, it's very hard to kind of figure out, okay, what two numbers multiply to give me this? Does anyone have it? No, it's two prime numbers. And they're integers. So yeah, it's quite difficult, right? It's quite difficult to reverse this operation. But if I told you that the answer is 43 times 47, you can easily confirm that this is correct. So you would just do 43 times 47. Oh, and this equals this. So yes, this is correct. So that's kind of how a hash function works. It's something that's easy to do one way, but difficult to do the other. So I guess what I want you guys to do right now is to create your own formula and maybe put like and make sure that the input and the output are both integers, and put maybe at least like 3 inputs into the chat and then 1 output, and we have to guess the input, and we'll see how that works. So basically just kind of do something like I did, just kind of create a formula, and once you have 3 data points, give us like 1 input, and we have to figure out give us 1 output, we have to figure out what the input is. So maybe like someone can do that. Yeah, so we want 3 inputs and their outputs. So like 1 and 2, 2 and 5, and 14 and 17. And then give us like 1 output, like, shoot, what is 8 squared? So I would give you like the output of 65, and then we have to guess, we have to figure out what this number is, what the input was. We have to decode it in a sense. So I'll give you guys maybe like 2 minutes or so to create one and put it in the chat for us to solve. And actually, I'll make my own as well for you guys. So I'll stop sharing for a second, and I'll see you at 4:51 maybe.
Wait, sorry. Do we give you like 1 input that you have to find the output, or 1 output that you have to find the input?
Give us like 1 output that we have to find the input.
Okay.
Okay. 2, 14, 39. Okay, and give us 1 of the outputs, Viha, and we have to find what of the input. Oh my god. Okay. It's all good, Jordan. You can just read it. Let's see. Quite difficult. Wait, let me, actually I'm gonna use, feel free to use your computers because you guys are going, well, you guys are going hard, so. Oh, you messed up too? Okay. Basically like 3 data points and just the output for one of them. Okay, but the same pattern as before, right, Jordan? 2, 14, 3, 49. Okay. Okay, let me find out. 2, 14. Wow. So yeah, feel free to decode or try to at least. I'm using like the regression stuff from Desmos to try to redo it. Oh, what? Dang it. I ended up getting. Oh, that is. Dang it! I actually could have. Trying to get Jordans right now. I got like a perfect match, but I'm pretty sure it's not the right thing. It's not 3.183 times the input to the 2.456, right? I guess 3 inputs isn't enough for the computer. Yeah, wait, can I have like 2 more maybe? Maybe I can solve it if I get 2 more. Five 185 and 10 810. Okay. No, I give up. I can't. I don't know. It's giving me weird things. just guess. Yeah, that's the way people do it. They just start guessing. And for the real hash functions. What's the answer, Jordan? What was the formula? $15. How? X squared plus. Huh. Interesting. Yeah, I would have never gotten that. But I can. Yeah, it is. Right? Because 100 plus 810. Oh, you're right. See, it's easy to verify. Easy to verify that it is not the right answer. Oh. Okay, whatever. It's fine. But yeah, basically the lesson is functions are usually hard uh, to reverse given the output. It's hard to get the input, but very easy to verify whether the input gives you the output. And you know, the equations that you guys came up with, a supercomputer would probably get. It would take like maybe a minute for it to crack, or maybe more. So these hash functions have to be extremely complicated, so that even these supercomputers, it would take them years for it to be cracked. Should have been 2-1. All right, that's all good, man. So I think that's kind of all I had. Hopefully you got an intuition of what a hash function is like, what its purpose is, and a bit about how how cryptocurrency is transacted and what Bitcoin mining is. So yeah, that's all I have for you guys. So see you next time. Peace.
Peace.
Bye.
Bye.
Bye. Be up.